Hello, and thank you for joining us. Today's webinar topic is Efficient Sample Preparation and Introduction Systems for In-Service Oil and Coolant Analysis. Our presenter today is Andy Perry, Technical Product Manager for Teledyne CETAC. If you have any questions, please feel free to submit them during the presentation using the question function, or send Andy an email directly and he will follow up with you after the webinar. This webinar is being recorded and will be available within a few days. Okay, now I'm going to turn it over to our presenter, Andy Perry.
Hi. Hello, everybody. As I said, I'm Andy, Technical Product Manager at Teledyne CETAC. And who are we? Teledyne CETAC Technologies started life as CETAC Technologies, founded in 1985 in Ames, Iowa, with the introduction of the U5000 ultrasonic nebulizer. It's a product which still lives on in its current version, the U5000 AT+. And in the early 1990s, CETAC introduced its first auto sampler, which laid the foundation for CETAC becoming the industry leader in auto samplers with a reputation for quality and reliability. CETAC was sold in the year 2000 to SD Acquisitions and then sold again in 2013 to Teledyne, where it became known as Teledyne CETAC Technologies. And then we're going to talk briefly, since we're talking about the oil labs, we're going to talk briefly about the makeup of the oil industry as a whole. Production of oil can be split into three major segments or streams. We've got the upstream, the midstream, and the downstream. And the upstream contains the exploration and extraction of oil and natural gas. And you'll find crude oil labs in this stream. And the midstream involves the transportation of oil and natural gas, and you'll find your inspection labs here. Downstream is where the crude oil and natural gas are turned into our finished products like gasoline or motor oil. Here you'll find your refinery labs, formulation labs, blenders labs. All the labs in these three streams are conducting analytical tests to ensure the product meets their specifications at that particular place in the production process. And then sitting apart from all of these is the in-service market, the in-service labs. The labs we're here to talk about today, they use analytical testing of oils and coolants more as a tool to determine the health of a particular piece of machinery. And in these in-service labs, they test fluids from a wide range of industries: agriculture, transportation, construction, power generation, or just a few. Anywhere there's an engine, a generator, or a gearbox, you may find an industry that's using in-service oil testing. And the in-service market can even be further broken down into additional segments. We've got the users of large equipment, and they may send fluid samples to contract labs for analysis. Equipment and oil manufacturers may provide fluid testing as a value-added service for their customers. And of course, we've got the military, which is a huge market unto itself. And these different segments may have slightly different priorities. For example, large contract labs, they may have a very strong focus on sample throughput, as this affects their bottom line. How many samples can you produce in a day? So we know who's testing, we know what's being tested, so we'll talk just briefly about the why. Regular testing of in-service fluids can tell a great deal about a piece of equipment. Is my machine healthy? Are we using the correct oil? Are there water or other contaminants in the oil? Do I need to change my oil at that time? And are some of my parts wearing abnormally? Is the whole thing about to fail? In-service analysis can help answer all of those questions, reducing planned and unplanned downtime, reducing fluid use, and improving mean time between failures. So it can be a very valuable tool and for saving money for their customers. So how does this testing happen? We'll talk about the actual workflow that we see in service labs. Everything starts with a sample. The sample is pulled from the equipment, usually by the operator or a maintainer of that equipment, and it's placed in a container for delivery to a lab. The path the sample takes to the lab is going to depend on the customer. Some of them may drive them across town to a lab. Some of them may be shipped. If it's a mining site, they might have a lab on site where they're doing the testing, within maybe a mile of the actual usage. But one way or another, it's going to make its way to the lab. And then once they arrive at the lab, they're going to be checked into that lab's LIMS. And after check-in, the samples are often visually sorted from clean to dirty. This is a way to kind of protect their equipment, get the clean ones out of the way so you get the best results on those, and then move on to the dirty. But after sorting, the samples can be mixed, and that's typically done to undo any settling that occurred during transport. And different labs are going to have different tools to do this, from your standard rotating wheel mixer to we see some where they use paint shakers that have been modified to fit sample vial trays. But after mixing, the samples are going to be ready for pour off. And during this step, the samples are poured into smaller individual vessels, and they're racked for multiple tests and techniques. And then those samples then undergo a range of tests like viscosity, ICP analysis, crackle testing, FTIR, and particle. And all of those tests, they combine to return some sort of data that's valuable to the testers and to the customer. So with ICP, and it has its own unique workflow, the samples will typically need some additional preparation before they're ready for analysis. Specifically, they need to be diluted. With oil samples, we see a 1 to 10 dilution with kerosene is very common. And once diluted, the samples are ready for introduction to the ICP instrument. And this task is handled by an auto sampler at most labs. And so where does Teledyne CETAC fit into the ICP workflow? And more importantly, how can we help you improve your ICP workflow? Well, we have a suite of products to help with both the dilution and the sample introduction phases. Starting with dilution, we have the SimPrep. The SimPrep allows you to automate the preparation of your aqueous samples. So we're talking coolants here for in-service labs. The SimPrep can free you from the tedious and repetitive task of manual dilution just by automating this process for you. Free your techs up to do something else. But the SimPrep, it's not just a diluter. It can also spike, split, serial dilute samples. It can even make your standards and calibration curves for you. So there's some real flexibility in the system as to what you can use it for. With serial dilution capability allows samples to be diluted to 1 to 10,000 and beyond. Such high dilutions may not be common in an in-service lab, but if the capability is ever needed, it is there. Right. And then we also have sample splitting, which can be very useful for an in-service lab. Now, if your current coolant workflow requires different dilution ratios for different tests using the same sample, you can let the SimPrep handle that for you. And here we're showing where we're taking one sample and we're making a 1 to 10, a 1 to 5, a 1 to 100 with a spike. All for different tests, whatever you need, the SimPrep can prepare that for you. And onto the nitty gritty, because some of you are going to want to know the details. So here they are. With dilutions of 10x, 100x, and 1000x, we are able to achieve precision between 9.95% and 1.31%. Accuracy of 0.35% for a full syringe stroke and 0.09% on a half stroke were achieved. To test carryover, we took a 100 ppm standard, diluted it 1 to 10, and then diluted a blank 1 to 10 after. We saw an average carryover of less than 0.0038%. So it handles carryover very well. All right, and then here we can see some of the SimPrep software. In this case, we're using it to build a calibration curve. You can see we're prepping a blank and 4 standards diluted from 1 to 5 down to 1 to 200. And all of them would have a final volume of 10,000 microliters. All right, and then these are just graphs that are showing what the SimPrep is capable of. We've got calibration curves for copper and boron. You can see both of them are nice and linear with a correlation coefficient of 4/9. So again, does very well. Can give you the accuracy and precision you need. And this can be specifically, again, suited for coolants. So that's the SimPrep. But anybody who has spent time in an in-service lab knows that the coolants are only going to make up a small portion of the samples coming in. Oil samples are the bread and butter of an in-service fluid lab. And for preparing those samples, we have a real workhorse. We've got the APS 7450V, the volumetric sample prep station. So what do you need to know about the APS 7450V? Well, it is fast, affordable, capable, clean, and simple. But I'll explain, starting with fast. I started out, I said it was a workhorse. Probably what I should have said is this is a racehorse, because the APS 7450V is truly fast. The 7450V is the successor to our APS 1650V, and if you're familiar with it, the APS 1650 could dilute a rack of 60 samples to 1 to 10 in about 45 minutes. Now, that wasn't bad, but we knew we could do better. The 7450V shatters that time by preparing 60 samples to 1 to 10 in only 20 minutes. So we're talking less than half the time. All right, and the APS is affordable. It uses few consumables other than solvent and vials, which is going to result in a lower cost of ownership. No expensive pipettes to buy. It's all probe-based. 7450V is also priced competitively, and it does not require a costly service visit to install it. It is self-installable. All right, and it is capable. Sticking with the horse theme I started earlier and seem to be developing here, the APS 7450V is not a one-trick pony. It's not just fast, it is capable of as well. It can handle dilutions from 1 to 5 up to 1 to 100, and it does this while maintaining accuracy of plus or minus 5% with RSDs under 2%. It works with a wide range of viscosities and performs well up to 700 centistoke. It also mixes the samples as it dilutes, and here in the graphic you can see the dilution of a 600 centistoke sample here. You can see it deposit the oil sample, and then it follows it with a high velocity shot of diluent, which mixes the sample. If you want to ensure the best possible homogenation, we do recommend pairing the APS 7450V with one of our oil 7400 or oil 7600 stirring auto samplers. We'll talk about them a little bit later. Sorry about that. Okay, and APS is also clean. It has a drip cup that swings under the probe whenever it is raised, so this prevents drips from contaminating your other samples. The rinse station is fed by a peristaltic pump, and with the default settings, you can achieve carryover of under 1%. Both the rinse parameters are configurable, so you have the flexibility to dial in the perfect amount of rinse for your method. Now, those features help keep your samples and your data clean, but the 7450 also helps keep its surroundings clean. The sample racks sit within a tray which can hold up to 5 liters of liquid, so keeping any spills contained and away from your bench or your floor. And the APS 7450 is incredibly simple to use. It's easy to maintain, it has a simple fluidic path, and the included oily software is intuitive to use. That simplicity means the 7450V is self-installable, which, as I said before, means you don't need a costly service visit to install it. You don't need to wait for somebody to come. You don't need to pay for them. It can just all be done by yourself. All right, and then the best hardware in the world is not worth a dime if the software controlling it isn't up to the task. When we developed the APS 7450V, we wanted to make sure we had software that wasn't just equal to the task, but was a perfect match for it. And the result was our oily software. It is simple to use, with many tasks requiring as few as 3 clicks to complete. It is intuitive to understand, but it has the flexibility to customize your methods for different sample types. and it includes the capability to import or export with your limbs. All right, and I alluded to these before, but we have the samples diluted, so we're ready to send them to the IPC, so now we need an auto sampler. The Oil 7400 and the Oil 7600, they're auto samplers purpose-built to serve oils labs. They are identical in capabilities to each other, with the only difference being the number of racks they can hold. The Oil 7400 can hold 4 60-position racks, while the Oil 7600 can hold 6 of the same rack. And while they have oils in their name, they can also handle coolants. Not only that, but we've built them to be able to easily switch between those two sample types. And two of the key features for the Oil 7400 and Oil 7600 are the stirring paddle and the drip cup. The configurable speed stirring paddle mixes the sample prior to sample introduction and ensures the best possible results. The drip cup captures drips, preventing them from contaminating other samples. The drip cup mechanism is much improved over our previous designs. There's no switches or springs to wear out. Instead, the cup is actuated by a cam that moves along with the probe and the stir mode. So as the probe and stir move up, the cup swings under them. It is very reliable, and our customers that have been using this love it. All right, and then the oil's awesome because they also have fast and smooth movement, and that movement translates into a savings of up to 2 seconds per sample compared to their predecessors, the ASX 1400 and ASX 1600. And the mechanics allow very precise movements. Now, how precise? Movement to the sample positions and rinse stations is kept within a tolerance of plus or minus 0.4 millimeters. The probe and stir panel are linked in a manner that you never have to worry about them drifting out of alignment. They will always be aligned with each other. All right, and then the Oils 7400 and 7600, they both come with a universal base plate which can accommodate a variety of rack types. You can use your standard basic Bellart racks. We have our own line of CETAC metal racks. We've got Bowden and Janus racks. They will all be accommodated on these platforms. And last but not least, we have the ability to easily switch between oil and coolant samples. And we achieve this by including 2 separate peristaltic pumps, a dual position rinse station mount and a dual channel rinse station. The rinse station has 2 completely separate fluid paths, including tubing connectors. And you can see in the image that on the lower one that we've got metal connectors on the oil side and non-metallic connectors for the aqueous or coolant side. But this combined with those 2 peri pumps, also labeled oils and aqueous, means you can leave all of your tubing in place for both types, eliminating the need to waste time changing it out when you're switching between sample types. You just simply slide the rinse station over to the second position on the mount, and the auto sampler automatically switches to using the other rinse station and other pump. You can even see the indicator light on the front of the auto sampler change color to show you which pump is now active, green for oils or blue for aqueous. And once you've moved the, excuse me. All right. Once you've moved the rinse station, the only thing left to do is to change your sample probe and stir paddle. Both can be done in just a few minutes. It's that easy. All right, so what could we do to make that auto sampler even better or maybe faster? Well, we've got the ASX Express Plus. The ASX Express Plus is like a turbocharger for your auto sampler. Traditional sample aspiration is driven by the peristaltic pump on the ICP. Sample travels from the tip of the sample probe to the nebulizer at the speed of the pump. Whatever the speed of the pump is running, that's how fast your sample is moving. The rinse solution follows after analysis, and the uptake and rinse times are all determined by the pump speed and the length of the sample tubing. Now, the ASX Express Plus is a high throughput valve system. It uses a 6-port switching valve paired with a vacuum pump to quickly load a sample loop. The sample is then driven from the loop into the nebulizer by a carrier solution. And that is pushed by, the carrier solution is pushed by the peristaltic pump on the ICP. The system rinses during the analysis. So what does all of this do for you? It lowers the sample uptake time, removes the rinse delay, and raises your sample throughput. And here you can see an animation of the process as it works. You see the green sample going from the auto sampler into the loop, and the vacuum pump is in control of this. So the actual loading of the loop is much faster than what this animation shows. After the loop is loaded, the valve switches and it directs the carrier solution into the loop. Air bubbles are introduced along with this flow. So as the carrier solution is pushing the sample to the nebulizer, it is also cleaning the loop in the process. There's a lot happening at once, and the result is a big time savings. All right, so here we have a time comparison between traditional sample aspiration and the ASX Express Plus. Using the traditional method, we come up with a time per sample of about 80 seconds. All right, using the ASX Express, we're able to go from 80 seconds per sample to 30 seconds per sample. So it's a savings of 50 seconds per sample. When you're running 500 samples a day, those 50 seconds can really add up. Here we've gone from over 11 hours to just over 4 hours. All right, and then those numbers show you that's what's possible, but I also want to take this opportunity to show what has already been done with some real world examples. Now, I can't share their names with you, but these are both real labs, and both were able to realize significant gains in operational efficiency and sample throughput by adding the ASX Express Plus into their workflows. I don't think I need to say anything else here. I think these numbers really speak for themselves. All right, so I have reached the end of our webinar. I want to thank you for sticking along with me. I hope I was able to effectively show you all the ways Teledyne CETAC can help you improve the efficiency of your in-service oils and coolants workflows. All right, and if I've piqued your interest, I encourage you to visit our website at www.teledynecetac.com. You can also reach out to me for product questions at andy.perry@teledyne.com, or for pricing inquiries, you can contact CETAC sales at teledyne.com. And thank you again, and I hope you enjoy the rest of your day.